Good morning, sir. My name is Babu Singh. Rule number 22951A 6715. Branch CSDA section and course code ACS C12. So here my topic is on the basics of reliable distributed storage networks. So reliable distributed storage networks are the vital in the digital age. Learn about the key exponents, challenges, and solutions to build this network. So here my agenda to discuss here is to in a brief introduction on this topic and what is distributed storage, importance of reliability, solutions for reliability distributed storage networks, components of reliability distributed storage networks, consistency models, common distributed storage technology, data sharding and partitioning, monitoring and maintenance, case studies, challenges of reliable distributed storage networks, future trends, and finally the conclusion of this topic. So here is a brief introduction of this topic. In today's digital era, reliable distributed storage networks have become essential. This section will define reliable distribution storage networks and their importance in data storage. What is distributed storage? So we discuss here what is distributed storage. Distributed storage referred to a method of storing data across multiple physical or virtual locations, often involve multiple servers or nodes. Unlike traditional centralized storage where data is stored in a single location, distributed storage system distribute data across a network of interconnected nodes. These approach offers several advantages including improved fault tolerance, scalability, and availability. In a distributed storage system, each node typically stores a portion of the data, creating redundancy and ensuring that if one node fails, the data remains accessible from other node. This redundancy enhances the system's reliability and the fault tolerance. Importance of reliability. The importance of reliability in various contexts, especially in technology and systems, can't be overstated. Here is a brief overview of why reliability is crucial. Continuous operations. Reliability systems ensure uninterrupted and continuous operations. These essential for critical services, applications, and infrastructures which downtime can result in financial losses, decreased productivity, or in case of mission critical system, pose serious risk. Customer trust and satisfaction. Reliability build trust among users and customers. If a system or service consistently perform as expected, users are more likely to have confidence in its capabilities. This trust is a cornerstone of customer satisfaction and loyalty. Data integrity and security. In data storage and processing, reliability is paramount to maintain the integrity and security of information. Reliable system may risk data corruption, loss, or unauthorized access, compromising sensitive information and violating privacy regulations. Cost efficiency. Reliable system can lead to cost saving in long term. This minimize the need for reactive maintenance, reduce downtime related expenses, and contribute more efficiency use of resources. So some of the solutions for reliability distributed storage and networks. RAID, redundant array of independent disks, an algorithm used for data storage that divides and replicates data across multiple devices. Assure coding, a technique that breaks data into parts and stores them across multiple devices, ensuring redundancy. Distributed file system. Similar to traditional file system, data is distributed across multiple nodes, providing redundancy and accessibility. Here some of the pictures which shows the RAID, ensure code, and the distributed file system. The components of reliable distributed storage networks. Replication. Data is present on multiple nodes on the network to avoid data loss. A consistency. Data remains consistent across all nodes on network. Availability of data. the network remains accessible even if some nodes fail, ensuring uninterrupted data access. Consistency models. Consistency models define how changes made to a system are reflected, observed by different nodes in a distributed computing environment. Sequential consistency. So here is a description about all operation on the system appears instantaneously and in the same order to all nodes. Key characteristics. Each operation is assigned a unique timestamp and all nodes observe the operations in same global order. Causal consistency. Preserving the causal relationship between related operations, and these operations that can causally related one precedent the other must be observed in the same order by all nodes. Concurrent operations be observed differently. Eventual consistency. Graduate Graduated that given enough time without updates, all replicants of the data will encourage to the same state. There might be a temporary consistency, but the system will become consistent eventually. Read or write consistency guarantees that a node will always see its own writes. After a write operation by a node, any subsequent read operations by the same node will reflect the updated data. So common distributed storage technologies. There are several distributed storage technologies that play a crucial roles in managing large volume of data across multiple nodes. Each technology has its own strength and use cases and features. Here are some common distributed storage technologies. So Amazon S3 simple storage service. Amazon S3 is a scalable object storage service provided by Amazon Web Service. It allows user to store and retrieve any amount of data at any time. So use cases are object storage, backup and restore, data archiving, and content distribution. Here the second one is Google Cloud Storage. Google Cloud Storage is an object storage solution offered by Google Cloud Platform GCP. It provides scalable and secure storage for various type of data. Here use cases are achieving data backup, multimedia content storage and distribution. The another type of storage technology is Hadoop Distributed File System HDFC. And HDFC is the distributed file system used by the Apache Hadoop framework. It is designed to store vast amount of data across multiple Academy hardware nodes. Use cases are big data processing, distributed computing, and Alanet. Apache is an open source distributed storage system that provides object block and file store in a unified system. It is highly scalable and fault tolerant. Cloud storage, visualization storage, and data backup and recovery. So data shading and partitioning. Here the definition of data partitioning or vertical partitioning is it involves dividing a data set based on columns or attributes instead of rows. Each partition stores a subset of attribute for entire data set. Virtual partition, how it works. Instead of splitting the data set by rows, it separates column to create more focused and efficient partition. In a customer database, one partition might store basic customer information while another partition store detailed transaction history. Benefit. Query efficiency. Reduce the amount of data read the certain type of queries, improving query performance. So there are some challenges which we can face in data shading and partition. Some queries may require access multiple partition, requiring careful consideration of data relative strategies. Change to the schema might impact existing a partition and require adjustment. The monitoring and the maintenance, regular updates, keep software and infrastructure up to date with the last apertures, schedule regular maintenance windows for updates. The data integrity checks, implementing uh, implementing check implementing regular data integrated checks to identify inconsistency, use checksums and verify mechanism of data integrity, node replacements, plan and execute replacement for fail and underperforming nodes, automated processor for seamless and node replacement, scaling operation, plan and execute scaling operation for growing storage needs, ensuring scaling operations and seamless and do not impact ongoing operations. So this is a case study on this topic. Amazon S3 scalable object storage is leading object storage. Amazon S3 is a leading object storage service used by business globally, implementing redundancy, automatically reflect the data across multiple servers, duplicate, achieving high durability through distributed storage across multiple availability zones. Outcome ensure high availability and fault tolerance for diverse applications such as website backups and content delivery. The Google Cloud Storage multimedia streaming scenario, a media streaming service reflects on the Google Cloud Storage for storing and servicing multimedia content, implementing shading duplicates media files across multiple storage shades. C&D integrated utilize Google C&D for efficient content distribution. Outcome ensure large latency access to multimedia content, high availability and scalability to handle vary user demand. So these are some challenges for reliability distribution storages. Network failures. Nodes can fail, causes data loss or reduce network access to. Data consistency issues. It is challenging to maintain consistency in data across all nodes on network. The scalability challenges. Adding new node to the network can be challenging and can be ensure data inconsistencies. So this is the future trend on these topic. Edges computing integrated over distributed storage networks are adapting to rise of edges computing impact, increasing demand for distribution storage solutions that support edge devices and decentralized data processing benefit reduce latency, improving performance and enhancing data availability for edge computing application. Machine learning integration overview. Incooperative machine learning algorithm for data optimization, predictive analytics, and the automated maintenance. Impact small data placement, predictive failure analysis, and the dynamic resources allocation benefit improved efficiency, predictive issue resources, and the optimized storage performance. So here is my conclusion on reliability distribution storage networks are essential in the digital era due to the need of large-scale data storage. These sections recap the key component challenges and the solutions of these networks. Building and maintaining a reliability distribution storage network require a careful planning and execution, but it is crucial to ensure data integrity and availability. And thank you for your opportunity. Thank you very much.